Okay guys, what we do today is going to be a little bit of a longer video, but this is going to be one of the most important things you guys learn throughout all of pre-cal. It's going to come up a lot. We're going to be using these all year, and you're definitely going to have to know these for calculus. So what we're going to find are called exact values. What exact values are is we're going to find the sine, cosine, tangent, secant, cosecant, or cotangent of some of the angles that we know on that unit circle, and we'll talk more about that in a second, but we're going to find those values without using a calculator, and we're going to find them exactly. And all exactly means is that we're going to use square roots, fractions in terms of pi, things like that. So we're not going to find any decimals or round anything in any way. So just a couple examples here. We're going to start with 30 degrees. So in order to find the sine, cosine, or tangent of 30 degrees, what I'm going to do is draw a 30-degree angle. I know 30 degrees falls in quadrant 1, so I label my angle. And then since I know that's 30, I know this is the 30, 60, 90 triangle. And we know every 30, 60, 90 triangle has the same ratio from our special right triangles. That ratio is x square root of 3, and 2x. So we can fill in any values here we want as long as they fit that ratio. So I'm going to pick the simplest values we know for this, which would be 1, root 3, and 2. So I'm going to go ahead and fill in those values. So across from 30 is going to be 1. Across from 60 is going to be the square root of 3. And across from 90 is 2. Once my triangle's filled in, I can find the sine, secant, cosecant, whatever I want based off that triangle. So the sine of 30, from looking at my picture, the ratio of sine is opposite over hypotenuse. That means the sine of 30 degrees is 1 over 2. I can do the cosine of 30 from the same picture. Cosine's adjacent over hypotenuse, so the cosine of 30 degrees is equal to the square root of 3 over 2. If you were to actually type in the cosine of 30 degrees in your calculator, you'd get a decimal value, and that decimal would be the same thing as the square root of 3 divided by 2. And then again, from that same picture, tangent of 30 degrees, and I would get opposite over adjacent. And again, what's nice here, we don't have to rationalize the denominator. I can leave that as 1 over the square root of 3. So what we want to look at now is what's going to happen when we look at angles in a different quadrant. This is when our reference angles are going to matter. So for example, I want to do the sine of 120 degrees. Just like I did the last one, I need to start by drawing a picture. So I'm going to draw a 120 degree angle, which we know is just short of 180, so it's going to fall in quadrant 2. Then, as we've done before, we're going to turn this into a reference triangle with the reference angle as our theta. So I'm going to connect this to the x-axis. I need to find now the value of my reference angle. So I know if it's 120 to that point, that in-between part has to be 60 degrees. So now I'm going to fill in those values for this 30, 60, 90 triangle based on where my picture is. So it's still going to be the same values. Across from 30 is still 1, across from 60 is still the square root of 3, and across from 90 is still 2. But what we have to realize now that's different, I now have a negative value on here. Because I've moved in the negative direction on the x-axis, that one value needs to be negative. Now it's not going to affect this actual answer because my sine of 120 degrees is the opposite over hypotenuse, which ends up being the square root of 3 over 2. But if I was looking at cosine or tangent, now that value would be negative. All right, so let's move on to another one. We're going to look at the cotangent of negative 135 degrees. Again, first thing I need to make sure I do here is draw my picture. I need to make sure I draw negative 135 degrees in the correct quadrant. That's going to terminate in quadrant 3 because I'm moving backwards 135 degrees. And what I'm going to do again is connect that to the x-axis and find my reference angle. So my reference angle here would be 45 degrees because 180 minus 135 gives me 45. So the distance between the terminal side of the x-axis is 45. What's really important here for these exact values is you always connect it to the x-axis. So I'm going to go ahead and fill in my missing sides of my triangle. This one's 45, 45, 90, so it's going to be slightly different values. My ratio for 45, 45, 90 is x root 2. So the values I'm going to use here are 1 1 root 2. And again, I need to check now for negatives, because I've moved in the negative direction on the x-axis and the negative direction on the y-axis. I actually have values of -1. But once my triangle is filled in, I'm going to find my cotangent ratio of the reference angle in that triangle. Cotangent is the reciprocal of tangent, so it's the ratio of the adjacent over the opposite. My adjacent is -1, my opposite is 1, or -1, which gives me a final value of just 1. So the cotangent of a -135 degrees is 1. So we're going to move on and do one more in radians, okay? Now, I went ahead and wrote the steps down here for you. This is exactly what we did for degrees. The only thing that's slightly different here is now we're graphing in radians. The best thing about radians, though, when you're finding your exact values, is that the reference angles are going to be very easy to find. One of the things we noticed when we first graphed some of those unit circle values is that every pi/6 radian value that was on that circle, or coterminal to something on that circle, had a reference angle of pi/6. It was also true for every one that was pi/3, and also true for all of them that were pi/4. So what that means for us, there's really 3 conversions we're going to have to know very, very well. And that is pi/6, pi/3, and pi/4. These are the 3 that are come up the most often. Any pi/6 radian value is going to have a reference angle of pi/6. But for the sake of drawing our triangle, we need to remember that pi/6 is 30 degrees. We need to remember that pi/3, let me go ahead and reorder these so they go from smallest to biggest. So pi/4, that's our next one, that would be 45 degrees. And then pi/3 is 60 degrees. You can always get any of these conversions if you forget, just simply by taking 30 degrees and multiplying by pi/180. You would still get there, but you're going to use these so often, you're probably going to have this memorized pretty quickly. So any pi/6 radian value is going to have a reference angle of 30 degrees. Any pi/4, reference angle of 45, and any pi/3 is going to have a reference angle of 60 degrees. What's really going to matter here is that we make sure we draw our triangle next to the x-axis. We always have to connect it to the x-axis for the sake of our reference angle. Another way to help you guys remember these little reference angles here, which one goes with which, pi/6, a lot of people want to think is 60 because they match that same number. Just remember, pi/6 is the smallest. 1/6 is smaller than 1/3. So that's why 30, that's our smallest angle. That's why it goes with pi/6. So what we're going to do now is we're just going to walk through these steps to find the exact value of the cosecant of 11 pi/6. So the first thing it says is draw the angle in the correct quadrant. So I know 11 pi/6 is just short of 2 pi, which is 12 pi/6. So 11 pi/6 is going to fall in quadrant 4. So I have that labeled. Now my next step is to find the reference angle. Well, all the pi/6s we know are going to have a reference angle of pi/6, which is 30 degrees. So my reference angle here is 30 degrees. Then I create a right triangle with the x-axis, so I connect that. Then I fill in my special right triangle values, and I make sure I watch for the pluses and minuses. So right now I can see I'm going to have one negative value here. Our hypotenuse, remember, just like those trig questions we worked earlier this week, the hypotenuse will always be positive. So now opposite of 30, I'm going to fill in 1, but make it negative. Opposite 60 is root 3, makes my hypotenuse 2. Once my triangle is filled in, all I need to do is find whatever the ratio it is it's looking for. So in this case, it's cosecant, which is hypotenuse over opposite, the reciprocal of sine. My hypotenuse is 2, my opposite is -1. That makes the cosecant value -2. So the cosecant of 11 pi/6 is -2. So what I want to look at now is how these exact values relate to something called the unit circle. And these are those radian values that we looked at earlier this week when we're finding the ones that had the same reference angles and things like that. We made them different colors. So what we want to look at on here is how those exact values relate. So let's start by looking at that 30-degree angle, which was pi/6. If I turn that into that triangle, that's how I've been working these out. What makes the unit circle different is that the radius of this circle is 1. So that makes my hypotenuse here 1. And I'm actually going to go ahead and move this to a different screen to make it a little bit easier to see. All right, so let's look at that 30-degree angle again. I turn it into the triangle. I know this angle here is 30 degrees. By making this the unit circle, it means the radius is 1. So that means the value of my hypotenuse here is 1. So what that means for us is this point right here falls on my circle. What I'm going to do is I'm going to find the coordinates of that point and see how it relates to the sine and cosine of 30 degrees. So the coordinates of that point, I need to find the horizontal distance and the vertical distance. So I basically need to solve a 30, 60, 90 triangle. So it has that ratio, x root 3, 2x. The value I know is 1, so that goes in the 90 column, which means that x is equal to 1/2, which means that the 60 side is 1/2 times the square root of 3, or root 3 over 2. What that means on my triangle then, across from 60 is root 3 over 2, across from 90, or across from 30 is a value of 1/2. So if you remember when we solved for the sine and cosine of 30 degrees, the sine of 30 degrees was 1/2. That's the y-coordinate of that point on my unit circle. If you look at the cosine, that's root 3 over 2. That's the x-coordinate of that point of the unit circle. So every point on this unit circle, the coordinates of all those points are going to relate to their sine and cosine. The x-coordinate is the cosine. The y-coordinate is the sine. So it's the cosine and then the sine. Now what that means for us is two things. That can help us double check our plus and minuses. So for example, if I look at this point over here in quadrant 3, that point, if I were to plot whatever point that is, I know it's going to be a negative and then a negative. It's going to be a negative x and a negative y. So I know my cosine is going to be negative and my sine is going to be negative in that quadrant. The tangent we also can get from cosine and sine. Tangent of any angle is the same thing as the sine over the cosine. And the reason that works out, it has to do, if you think about it, sine is opposite over hypotenuse, and I'm dividing that by adjacent over hypotenuse, which means when I divide, I actually flip, which means I'm doing O over H times H over A, which gives me over A, which is tangent. So that's kind of why that works out. But tangent is the ratio of sine over cosine. So I also can get my tangent coordinates using that sine and cosine. And we'll talk more about how this unit circle relates in class, because I know this part's very new. What's important now, though, is just seeing how those plus and minuses can relate and how it's going to relate to what we talk about on our next picture. So since I know the cosine corresponds to the x-coordinate, and let me call that theta instead of x. So the cosine on the unit circle is the x-coordinate, and the sine on the unit circle is the y-coordinate. That can help me figure out the values of the ones that fall on the lines. So the ones that fall on the line is when we have a problem, because you can't draw a triangle when it's on the line. So these are going to be values like 0, 90, 180, 270, or the equivalent radians that go with it. So like 2 pi, pi over 2, things like that. So if I want to use 2 pi, pi over 2, pi. If I'm trying to find the sine, cosine, or tangent of those values, it's important for me to know that the cosine is the x and the sine is the y. And in this case, the tangent is sine divided by cosine, which is the y over x. So again, if I were to look at this as the unit circle, this point right here, if I'm going a distance of 1 away, the coordinate of that point is 1, 0. The coordinate of the point up here is 0, 1. The coordinates of the point over here is negative 1, 0. And the coordinates of the point over here is 0, negative 1. That means the cosine of 0 degrees is 1. That means the sine of 0 degrees is 0. That means that the cosine of 90, or pi over 2, is 0. The sine would be 1. So if I can just remember the coordinates of those points, then I can remember what the sine and cosine are. Tangent, I get by dividing. So in this case, tangent would be sine over cosine. 1 divided by 0, we can't divide by 0, so it's undefined. And if you want to see something really funny, you should ask Siri what 0 divided by 0 is, and it gets you a pretty good response. Tangent in this other case, if I do 0 divided by 1, that's okay. 0 divided by 1 gives me 0. Now, there is a little trick to help you guys remember these quadrant border angles, and you can use this if you need to. You just have to make sure you get it right. So there's a little saying, and it's based on, I go the sine, cosine, tangent order. And that's the hard part because that's not the coordinate order, that's your SOHCAHTOA order. So that's where a lot of people get confused. But I go from 0 to pi over 2 to pi to 3 pi over 2. And the little saying that I can use to help me remember these, the saying is O I owe you. Oh, I don't owe you. And the way that relates to my points, I'll just fill them in. O I owe you. Oh, I don't owe you. And we can use this to help us find the ones that fall on the line. So for example, the cosine of pi over 2 is 0. The tangent of 3 pi over 2 is undefined. The sine of 3 pi over 2 is -1. And that works for coterminal angles as well. If I want to find the sine of negative pi over 2 is coterminal to 3 pi over 2, so that value would be -1. So that's just a little bit of an easier way. You just have to be careful with this because if you mess it up, you're going to get wrong in all the values. So I would always use those coordinates to double check to make sure you're actually filling in those values correctly. All right, so that's summing up exact values for you guys. We're going to talk a little bit more about these in class and do a lot more examples to get you guys some practice. And we're also going to talk about that unit circle a little bit more in depth and kind of go over some more of those points. But that'll be in class tomorrow. Just remember your quiz on Friday is not going to include these exact values, so don't stress about getting them done right now immediately. We're going to work on this some in class tomorrow. We're also going to work on this next week before your test, so you're still going to have some more time to work on this, kind of process these, because I know they're new and they're very important. But if you have questions, bring them to class and come ready to work tomorrow.